Welcome to the video for areas and volumes of similar figures. So first I want you to recall the scale factor is the simplified ratio of corresponding sides of two similar figures. Also remember, when it comes to the perimeters of similar figures, the ratio of the perimeters is equal to the scale factor between them. So now let's look at the situation. We're given a square whose sides are 2 inches and a second square whose sides are 3 times the first square. How many times bigger will the area of the new square be? Well, let's look at that. We have a square and its side is 2, and then we have another square and its side is 3 times that. This is probably not drawn to scale, but 2 times 3 is 6. So all the sides of this square are 6. So let's see. When we find the area of a square, we say 2 times 2, and square side squared, and so that's 4. And this one will be, the area is 6 times 6, and that is 36. If I divide 36 by 4, I get 9, and so my new square, the area of my new square is 9 times bigger. I know the side is 3 times bigger, but the area is 9 times bigger. Well, that's because when we talk about the areas of similar figures, if two polygons are similar, then the ratio of their areas is equal to the square of the scale factor. Let's think about this one though. Given a cube whose edges are 2 inches and a second cube whose edges are 3 times the first cube, how many times bigger will the volume of the new cube be? So we've got our little cube here, and all the sides are 2, and we have another cube whose edge is 3 times bigger. That makes it each side 6. So the volume for our small cube is going to be the area of the base times its height, and with a cube it's 2 times 2 times 2, so we have 8. Then we have, for our big one, our volume is equal also to the area of the base times the height, and then the base is 6 by 6 and the height is 6. We get 216. So I know that, let's see what the ratio here, I know that my side is 3 times bigger, but when I take 216 and divide by 8, I see that my volume is 27 times bigger. So the volume of the new cube is 27 times bigger. 27 is the same as 3 cubed, which makes sense because if two solids are similar, then the ratio of their volumes is equal to the cube of the scale factor. Okay, so in summary, if similar figures have a scale factor of A over B, then the ratio of their sides or other parts is also going to be A over B, and the ratio of their perimeters will be A over B. They're all equal. Okay, but when we talk about the ratio of areas, we get A squared over B squared, and volumes is A cubed over B cubed. Make this into a little table here. So this is similar figures. If they have a scale factor of A over B, then the ratio of sides is also A over B. The ratio of perimeters is A over B. The ratio of areas is A squared over B squared, and the ratio of volumes is A cubed over B cubed. For each pair of similar figures, find the area of the shaded figure. Round to the nearest tenth if necessary. Okay, so what we're going to do first is we want to find the scale factor. And so we look for a pair of corresponding sides, and I see that the 5 and the 15 are corresponding sides. And so we're going to say that the scale factor, or 5 over 15, and that is equal to 1/3. So 1/3 will be my scale factor. So I'm going to reduce it first. Then I want to find the area of my shaded region. So the unshaded region has an area of 12. And so if I take my scale factor and I square it, that's going to equal to the areas in a ratio as well. And I don't know what this one is. So this will be 1/9 equals 12 over x. And so x is equal to 108, and that's meters squared. And so that is going to be the area of the shaded region on that one. All right, let's do it again. We're going to take our pair of corresponding sides and put them in a ratio to make the scale factor. Okay, and so when I do that, I get 21 over 31 when I reduce the ratio. So that's my scale factor. So now when I want to solve for the area of my shaded region, I put the scale factor squared equal to the ratio of my areas. And so my area of the small one is 200, but the area of the big one I don't know. So these squared becomes 441 over 961, and that's going to equal 200 over x. So I cross multiply, 441x equals 961 times 200. And then I'm going to divide by 441, and I get x is equal to 435.828 centimeters squared. First, you're going to find the scale factor, and then you square it and set it equal to the ratio of your areas. Let's look at a couple volume problems. So two suitcases are similar rectangular prisms. The smaller suitcase is 68 centimeters long, 47 centimeters wide, and 27 centimeters deep. The larger suitcase is 85 centimeters long. All right, so it's telling us that these are the long side, okay, is 68 centimeters long versus 85 centimeters long, and that's the common side or the corresponding side. So I'm going to go ahead and set that in a ratio so I can find my scale factor. So my scale factor of the prisms is going to be a pair of corresponding sides set up in a ratio. 68 over 85. And that reduces to 4/5. So this is our scale factor. So now we want to find the volume of the larger suitcase. So to do that, we're going to cube our scale factor. And then we're going to put the volume of the small suitcase over the volume of the larger suitcase. All right, 4/5 cubed is 64 over 125. We need to find our volume of our larger suitcase. So now let's figure out the volume of our smaller suitcase since we have all of the dimensions of it. All right, so 68 times 47 times 27 is 86292. And now we cross multiply. 64x is 86292 times 125. And then we're going to divide it by 64. And so the volume of the larger suitcase is 168,539.063 centimeters cubed. What is the volume of the larger solid shown below? So we don't have all of the measurements, but to find the volume, so we're going to use the similar figure. And first, let's find the scale factor. We notice that this has a diameter here of 16, and this has a radius of 6. So I can say that my radius over here is halfway, and it is 8. All right, so my scale factor of small to big is going to be 6 to 8 reduced, and that's 3/4. This is my scale factor. So to solve this problem, I'm going to take this scale factor and square it. I'm going to cube it because I'm going for the volume. And I'm going to set it equal to the volume of the small solid and over the x, which is my volume of this large. The next step is to figure out what the volume is for the smaller solid, and then you'll place it here, and then you'll cross multiply to solve for the volume of the larger one. Let's look at scale factors and missing measures in similar figures. You can use the areas of similar figures to find the scale factor between them or a missing measure. First, let's find the scale factor. So we start with what we know and we bring it down to the scale factor. All right, so we are missing x. We know that these two figures are similar, and we also know the ratio. We know our areas. So if we make the ratio of areas 64 over 49, we know it's going to equal to our scale factor squared. So if I take the square root of both sides, the square root of 64 over the square root of 49, it's going to equal 8/7. And so this is my scale factor. And then I just use the scale factor to find the corresponding side that's missing. So 8 over 7 equals 10 over x. And so 8x equals 70, and x equals 8.75 meters. So we just have to take the square root of that, and when we do volume, we'll take the cube root. Let's look at the volume problem. We're going to find h for the smaller container. So we have our volumes, so let's put them in a ratio. 270 pi divided by 640 pi. And of course we want to simplify that, and our pi's simplify right out, so do the zeros. 27 over 64 does not reduce anymore. So we have the ratio of our volumes, and that is equal to our scale factor cubed. So we'll take the cube root of 27 and the cube root of 64, and we get 3 over 4. So this is our scale factor. Using the scale factor, we will find the missing height. So 3 over 4 equals h over 10. Cross multiply, 30 equals 4h, and h equals 7.5 inches.